This talk is how Spotify built a robust Ray platform with a frictionless developer experience. My name is David, and I'll be co-presenting this with my colleague Keshi. Yep, there's the two of us. I'm a senior engineer on Spotify's ML platform team, and Keshi's a staff engineer on the same team. And today we'll tell you, again, how we built an internal platform on top of Ray. This talk is split up into two parts. The first part's actually not, it's like pretty ML agnostic. It's a little bit of background on Spotify, our local development problem, the cloud development environment solution we came up with, and the lessons we learned from that. And not much of this is actually ML. You could apply this to like backend or web, but what's specific here is how we actually used Ray as part of this cloud development environment solution. So Spotify is an audio streaming platform with over 515 million users and 210 million subscribers across 184 markets. Hopefully a lot of you have tried it out and used it. And machine learning is at the heart of a lot of the things we do at Spotify. Applications include recommending personalized content on the homepage, optimizing ranking results from searches, helping you discover and explore new audio content. So to power all of these ML products at Spotify, our team is building and managing a centralized machine learning platform that provides our engineers with the tools and environments to quickly productionize their ML applications. And the name of this internal platform is called Hendrix. In a nutshell, Ray clusters on the platform are deployed onto Kubernetes, and we also use GCP. So we use GKE, or Google Kubernetes Engine. You've got GPU nodes attached to it. We use the open source Kubernetes operator called kubray. And then on top of that, we built a Python SDK that includes Ray and PyTorch libraries. It has about 100 users currently inside the company. This is a slide about our diverse potential users, like all the different types of people we want to serve at Spotify. So an ideal ML platform should cover both breadth and depth of users and offer a wide range of tools to tackle different problems in a scalable, maintainable, and enjoyable way. So we wanted a unified and easy-to-use interface to access managed Ray infrastructure for users of all these different types of backgrounds. And it spans the range from research scientists who prototype and experiment on new ideas, data engineers who explore and optimize features, to ML engineers who implement and productionize models, and also data scientists who analyze and A/B test results, and also like back-end engineers who want to serve that final model in production. And I want to emphasize that these groups of users, sometimes there's definitely overlap, but there's often vastly different backgrounds that they come from. For example, back-end engineers probably know how to SSH into a machine, but some data scientists or maybe even researchers, they don't know how to do that. Or if they do, they don't know things like, how do I forward my agent so I can get pushed? And I'll get into why that's important later. So we wanted to create a platform that would simplify and cater to all these different types of users. This is the part where it's kind of ML agnostic, but it's exacerbated by the ML ecosystem. We built Hendrix SDK, and most of our users have expensive MacBooks, usually the newer ones, M1s, M2s. Okay, some of you probably already know where I'm going with this. But the culture at Spotify is you work by default locally. You try to set up your local workstation. There's not really a tradition of starting in the cloud. So people will try to pip install Hendrix, and they have a variety of different workstations. You know, CPU architectures can be different. Their operating system can be different from one to one. They have different Python versions that they're using. And bam, they're hit with like, can't pip install failure, can't install like gRPC-IO. I'm just curious, like how many of you have actually run into some kind of weird Apple Silicon, yeah, so I see a bunch of hands and like, how much of a productivity killer is that, right? Like you don't want to be, you want to be doing ML, you want to be doing like AI stuff. You don't want to be Googling obscure compiler flags so that you just get the thing installed. So our support burden was like just horrible. And even if they did, let's go on to number 2, like even if these users did manage somehow, if they run into these bad edge cases of being able to like install stuff locally, then when developing their Ray applications interactively and connecting to a remote cluster, so our infrastructure helps them create a remote cluster, and then we have to connect to that. They're writing code locally, connecting to a remote cluster. They have oftentimes trouble achieving like consistency between their local development environment and the remote runtime environment, which is really important. And Ray, in the best case, tells you you're using different Python versions, I'm not gonna run your code. And the worst case scenario, it runs it, but your checkpoint is null for some weird reason, right? So strange bugs when running on a Ray client that's not a Ray, on the Ray cluster. And users have to spend also time setting up their development environment for each repo. Spotify is a mono-repo company, or sorry, it's not a mono-repo company, it's like multi-repo, microservices, so a lot of times users have to switch between different repos, and each repo might have different setup or different configuration, new PyEnv environment for each one, different pip requirements files. So juggling all of those different Python virtual environments can also be kind of, that context switching can be tedious and error prone. And then, yeah, at the very end of the day, it often boils down to lots of Slack requests for help of, this doesn't work, why, help me. We wanted to reduce and solve all of these problems. So cloud development environments. We figured it's very hard to support and maintain and make sure everything works on all the permutations of local workstations and CPU architectures, Python versions. Why not just standardize and work in the cloud? Linux x86 usually works for everything. At least the ecosystem has like first-class support for this, right? So basically we're building, actually a show of hands, how many people have used like a CDE, kind of managed CDE solution like GitHub Codespaces? Raise of hands. Okay, so see a few hands. So basically we're building that, but with Ray and GPUs. And for those of you who've tried out the AnyScale platform, yeah, we're basically kind of building an internal version of the AnyScale platform at Spotify. The benefits are that people can start coding instantly. You've got fully configured dev environments starting in seconds, no more time wasted fixing broken dev environments. They're more powerful. So when you're running small models, sure, but when you're running or training or serving big ones, you want more CPUs, memory, specialized hardware accelerators that your local workstation usually just can't provide. You can work from any device. We first-class support VS Code in the browser. It works the same on any device. You don't have to mess with it. And frictionless experimentation. So people of all backgrounds can onboard very easily, which is super important at a large multi-repo company like Spotify. We had certain requirements for these CDEs, basic functionality and security, persistence, reliability, and resource customization. And very important was fast startup and low latency. People who are coming from a habit of working locally expect something in the cloud to be very fast and performant. If it starts slow, it's usually going to be hard for them to adopt it. So when we were building it, we had all these things in mind. This is a slide about a little bit of context at Spotify and why usually, a caveat here is that building a platform like this doesn't make sense for every company. If you're a small company that doesn't have the resources and the staffing or expertise to devote to building a CDE platform using Ray, AnyScale platform is great. You can start off with that. But if you're in our boat, things may be different. So some history. The original CDE platform at Spotify was a Jupyter Hub-based platform for data scientists, really just running SQL queries, exploring data, and then the ML platform team, we created a CDE prototype for our own ML users. that showed some promise and actually gained some traction. And then we decided to consolidate these two efforts and build one CDE platform to serve both groups of users, because there's a lot of overlap between the data discovery and data exploration side of things, and then the transition into doing some ML based on that data. So this actually justified, we tried using the old Jupyter Hub-based platform, but it was just, had a lot of old assumptions that were outdated, and it wasn't flexible enough to accommodate, for example, like running a Ray cluster as a custom resource in Kubernetes. So it really justified a complete rewrite of the entire original data science CDE platform to be more powerful, performant, and flexible. And it's just a prototype, even today, it's just a prototype, but it should make a big impact because the total internal, like, addressable market at Spotify internally is about 500 to 1,200 users. Spotify is like that, I'm gonna get the numbers wrong, but it's like northward is probably of like 10,000 employees, and this many people actually do run like SQL queries or do some kind of data science or ML, have ML use cases. That 1,200 is actually like, if you include all people at Spotify who use Google BigQuery in some way, or potentially could use it in some way. We went through the decision-making process of like, do you buy versus build? And again, landed on the build part because we have the expertise and the staffing. We really needed deeper integrations with the rest of our platform, like Backstage, which is an open source thing that manages like your internal software catalog. We also need a lot more control over VS Code, specifically the custom extensions. So we've written a lot of custom extensions to hook into other parts of Spotify. For example, you can query like internal data endpoints straight from VS Code. SQL writing to be able to write custom SQL writing, and then being able to run like a custom SQL engine underneath that. And then also we wanted more granular telemetry down to the level of Python notebook cell execution times and what people are actually running in their Python notebook cells. So all of these reasons are why we decided eventually to build this thing internally. This is, I know it's very hard to see, and I'm looking at the time to see if I have enough time to go into this. I'm gonna go very quickly, but this is the system design. And in a nutshell, people can access these CDEs or create one through their terminal or through their browser. And we have a backend service that creates inside, this is all in Kubernetes. We have a backend service that creates the Ray cluster custom resource. We then wire the whole thing up with Istio to do the networking and the security. And of course, we use a GCP load balancer to kind of distribute and proxy all the requests. There's a lot here. I don't think I have too much time to dive into it, but I wanted to go to a quick demo. I'm gonna try to demo this live. If it goes badly, I have a video backup, so we'll see. Pray to the demo gods, because I've seen so many live demos this conference, so I wanna try one. How do I, oh, I have to like, there we go. Okay. Doing two screens is hard. Okay, so here, what you're seeing is kind of like, we have a Hendrix CLI, and we build functionality so that you can list your CDEs. So here you can actually see like namespace CDEs, the name. This one's regional ramp. It's the only one that's ready. There's some stuff that we didn't do, so that's the to-dos. We have a column called, those are the actual number of Ray workers in this CDE, so it has 2, and how many hours it was live. What does this look like from a user point of view? This is our GitHub Enterprise. This is the Hendrix SDK itself. So let's say I want to develop this thing, right? Got a nice little button here. This button says open up this repo in the CDE. And imagine this was like a Ray repo, right? So you've got some Ray code. Then you see this welcome screen. It's gonna load. It's gonna take a little bit of time to load. But in the meantime, I have an already opened one. So what it's gonna do is once your CDE is ready, it's gonna drop you into VS Code. Your repo is gonna be cloned. And then from there, you can just open a Python notebook and just run all the cells. So for people who are coming from a lot of diverse backgrounds, in like a click of a button, they can just get started. They don't have to worry about how do I connect to the Ray cluster, how do I SSH in? How do I push, even if you want to like make some changes to these files, and you can just push it to GitHub because your personal access token is already there. They don't need to know about how to like forward their SSH agent. So this should be running. You can see that this cluster actually has, do I have it up here? Yeah, it's a little small, but I created this cluster with 2 GPUs. So it has all the power of like GPUs, and it's just going through this example notebook where we're preparing training data, doing the splits, and actually training and doing the fitting. And then going back to this, yeah, this CDE over here is also, just to show you it was real, it came up, it cloned the repo, everything works. Let me switch back to this. Yeah, that was the, okay, so some lessons learned. What do we learn from all this prototyping? We learned that you have to ensure availability and performance. You know, there's like, you saw there was a reverse proxy in the system design. That needs to be fast and highly available. Startup times must be fast. We also learned that we should allow for a lot of customization and extensibility. People, first thing they ask is, okay, great, I want my dot files. Or how do I customize my repo so that I have pre-commit hooks? There were like 2 levels of customization. One was for personal customization. People might want to use Vim key bindings. Other people are Emacs. Then there's repo level customization where there's like a certain number of setup steps for the repo to get initialized properly. A lot of times it's just like pip install, make sure every dependency is installed. A lot of people ask for JetBrains support and SSH because they weren't used to VS Code. And we learned to leverage VS Code extensions, pre-install commonly used ones, create custom ones to integrate with the rest of your ecosystem. And we also learned to really just, from our security teams, encouraging us to design for security and telemetry. And also hopefully being able to apply like security auto updates. And we also learned to design for efficiency and cost savings. Users forget all the time to shut down. So we would like to build like idle shutdown. And we learned to also really leverage, we're all on Kubernetes, so really leverage Kubernetes if you're using it, using the etcd as a database. Try not to have like external data store if you don't need it. So you have one source of truth. And we learned a lot about how to just design stuff on Kubernetes in general, using like a custom resource. In our case, it was called a workbench. The CRD will really abstract away a lot of underlying Kubernetes resources and details, and then provide like a higher level primitive that the rest of the platform can build on top of. And I think that was mostly it. I'm going to transition to then giving the talk over to Keshi, who's going to talk about the ecosystem on Ray, and this will be much more like how do we actually have Ray use cases at Spotify. But first, I think I started without the speaker notes, so let me go back to that. Okay. And here you go, take it away.
Yeah, thank you very much, David, for introducing our new cloud dev environment. Now I'm going to talk about the ecosystem around Ray at Spotify. So as we saw earlier, and the new cloud dev environment offers ML practitioners a managed, user-friendly interface to leverage Ray to solve many ML problems. So for ML researchers, Ray's flexible and easy-to-use distributed compute framework can help them to scale the training job for advanced problems such as neural network, the graph neural networks, and foundations models. For data scientists, Ray's ecosystem around the small thing attributes can help them solve forecasting problems and speed up the Panda workflows on large data sets. And for ML engineers who are mostly building the ML systems, Ray helps them to prototyping the new ideas and provides common operations around PyTorch. So let's zoom in a little bit and talk a little bit more about the PyTorch support on Ray, and we have been working on since this year. So historically, our ML platform has been standardized around a TensorFlow ecosystem. With the rising popularity of the PyTorch, and more open source models and the toolings have been developed solely for PyTorch. So to quickly bootstrap the PyTorch ecosystem support, we decided to leverage Ray as much as we can to reach the feature parity with the TensorFlow ecosystem. So why do we choose Ray? First, Ray AI supports many common ML ops, such as feature pre-processing, distributed training, parameter tuning, and batch prediction. So these provide the building blocks for common ML tasks for PyTorch. And second, Ray also comes with a great ecosystem support. Users can easily access popular ML libraries such as Hugging Face, DeepSpeed, PyG, and so they can bring in many novel solutions. So the KubeRay manages our Ray infrastructure at scale. It creates ephemeral clusters for scheduled workflows. It has been integrated with Flight, which is our workflow orchestration system at Spotify. Lastly, Ray's distributed application is just a regular Python program. It's easier to demonstrate through the notebooks, as we just saw the example David showed us. So we can provide end-to-end notebooks for different ML use cases and ship them with our SDK. So overall, we built our platform around Ray ecosystem with 3 core components. Hendrix Compute, Hendrix ML Ops library for PyTorch, and open source ecosystem integration. The bottom foundational block is what we call Hendrix Compute, which is managed Ray infrastructure. It provides a standardized interface for users who don't know much about Kubernetes knowledge to interact with the Ray infrastructure on our GKE. It also offers GPU management, network optimization, and resource scheduling, and different runtime environments for different ML problems. On top of that, we have our ML Op library for PyTorch. This SDK does the heavy lifting for users to accomplish common ML tasks. It provides many standardized operations, including feature engineering, training, serving, and experiment tracking. They are the cornerstone of unifying the user experience on our platform. But there will be still use cases that cannot be well addressed by the ML Ops, standardized ML Ops. They are either due to the emerging topics in ML research or very specialized process for ad hoc ML workloads. For those use cases, users can still rely on Ray's broader ecosystem to solve their own problems. So this gave advanced ML researchers and the data scientists more flexibility to build their own solution on top of our platform. It also gave us the opportunity to standardize them in the future when they become more common and mature. So with all those 3 components and the newly developed cloud dev environment, we look forward to the Ray ecosystem at Spotify to drive more ML innovations and keep our customers happy. So in the future, we are going to complete PyTorch development on Ray to support more production workflows. We will optimize ML compute accelerator regarding to resource allocation, cost optimization for Hendrix Compute. We also plan to build LLM ops support on Ray. Last but not least, we are going to further platformize our Hendrix Compute as a service to offer better accessibility, reliability, and observability. So that concludes our talk. In the end, I would like to take this opportunity to thank everyone at Spotify ML and analytics platform teams for their amazing and hard work. So David and I can have this opportunity to give this talk here at the Ray Summit. We also want to thank AnyScale and the Ray open source community for all the help and the support we have received. That's it. Thank you very much. Oops. Oh. David, do you want to repeat the question?
So the question is, so the question was, with the CDE, how do you ship the code or the notebook? How do you get it into the CDE? Right. So you saw that button that I clicked? If it's in the repo, that repo is cloned down, and then you have all the things in the repo in the CDE just automatically. And then you're just editing live files that are remote. Yeah, does that answer? Okay, cool.
How do you handle unsaved changes in the machine that you actually turn on, like for the CDE?
Yeah.
How do you handle those unsaved changes?
Right, the question was how do you handle unsaved changes or work in progress in the CDE? Yeah, it's all Kubernetes, and of course, you know, pods are ephemeral, so if they get restarted, the data's gone. Unless we mounted persistent volumes into them. So those on GCP are backed by GCE persistent disks. Even the pod restarts, new pod comes up, the mount happens again, all the work is there. So if it's on disk, it's saved.
I see. If the machine is idle for quite some time and your system decides to shut it down, will the work get lost or will it be restored?
Right, the question was, what if the CDE itself is shut down, or you know, what happens to the work on that persistent disk? So we have, I think what we're planning on doing is we have functionality so that you can, like a user can just stop. We have this like state changes, like there's a concept of a state where the CDE is stopped, and there's a concept where the CDE is like entirely deleted. Stop just means that the compute resources, like the Ray cluster, that Kubernetes resource is deleted, so it's releasing the CPU, the memory, the GPU, but stopped does not delete the persistent volume. So that remains in the Kubernetes cluster. And then we're thinking about even if someone deletes their CDE, maybe sometimes they're gonna do it accidentally, right? And then they're gonna wanna recover something. We're thinking of even then, not deleting the persistent disk, maybe a retention policy of 30 days. So give them 30 days to kind of change their mind, we can still recover the stuff that they had on the disk.
Thanks. I heard that developers at Spotify use the Backstage. So does this just parallel to Backstage or it checks the code back?
Yeah, do you want to take this one or?
Yeah. So yeah, it's a little bit different. So this is the separate project we have at ML platform. So Backstage is the portal, but in the future, maybe that can be a Backstage plugin.
Yeah.
Something like that.
Yeah, I think the question was we had like Backstage. How does this go in relation to Backstage, the CDE? I think they're kind of complementary. They're orthogonal. Like there's ideas floating around, like Keshi said, of building a Backstage plugin or integration in the form of maybe like a VS Code extension, right? So you can browse other stuff in Backstage directly from the editor.
Why did your team decide to pick Istio as a networking layer over
Yeah.
the regular networking from Kubernetes?
Yeah, the question is, why did we choose to use Istio as the networking layer of the CDE system instead of using just the Kubernetes, like native Kubernetes things? We needed our specific requirements were we wanted HTTPS, so when you go to your CDE, it has to be secure, a memorable URL. I don't know if you noticed, but the URLs were some adjective dash noun and randomly chosen, so sometimes you get funny combinations, and then like hendrix.spotify.net. It's gonna be workbench.spotify.net, but it's not, you know, details. So something memorable with HTTPS, and the DNS has to be instantly routable, right? Like these are gonna be randomly generated dynamic host names that have to be instantly routable, and also just basic create, read, update, delete on them. The one that we found that worked pretty well out of the box was Istio. And it mapped pretty well. You could have like an Istio gateway, all the traffic comes in, and then it's a reverse proxy, and then you can set up things called like virtual services where this host name goes to this pod, this other host name goes to this other pod, and it also had really nice out-of-the-box security. We could issue JSON web tokens so that only you can access the CDE that you created. No one else can. And that was done through an Istio resource called, it's a combination of like request authentication plus the resource or authorization policy. But yeah, a lot of Istio things, and almost all of it was just like north-south traffic, because you're talking from outside the data center into the data center, not a lot of the east-west, which is what Istio is probably better known for, a lot of like service mesh east-west traffic, but we're just using the north-south and it works out pretty well too. There may be other solutions out there, but we haven't like fully explored it. Yeah.
So for your users, is the array cluster shared or do each user get their own array cluster?
Yeah, so the question is, our array class is shared by different multiple users, or everybody has to get on its array cluster? So it's kind of mixed. So in this case, in our setup, on our GKE, every team has its own namespace. So they can, every user can create their own array cluster. But if they want to share with the cluster with their teammates, they can also do that. That's a good question. So the question is, we have Flight integration. What's the relationship with CDE and Flight? So the CDE is more for the interactive development experience. The Flight is more on the production side. Say, I'm working on a new ML problem. I use CDE to build an ML pipeline. After that is done, we're going to use Flight to orchestrate and schedule it to run in production every day. Gotcha. So the question is, during the interactive development mode, does the user write Flight code directly in CDE? And the current answer is no. So there's we have our own Flight plugin in our SDK. So what people usually does is they build the ML applications using our API. So they cannot build it on top of us. Then they have their own functions, libraries. Then on the Flight side, it's simply just call certain APIs for each Flight task. So on the Flight side, the logic is relatively simple. So they trying to wrap up everything in one Python module. Then Flight can call that, call those functions in the Python module. Yeah. Good question. Do you want to take that one?
Yeah, so at this point on our Ray journey, we're using just kind of a subset of Ray. And I think, or the question was, we're integrating with Flight. What else is needed for a minimum viable platform, I guess, right? Okay, so we have Flight. It really depends on the use case and the business problem you're trying to solve. In our case, we already had a pre-existing ML platform, which was great for production, scheduled like production offline batch jobs based on TensorFlow. And what we were missing was a product or tool or platform for AI researchers, people who wanted to prototype, not really sure if it's going to go into production or not. And that's where Ray really stood out, and that's where we really wanted to develop towards or address that need. In terms of, we're using a subset of Ray right now. So because we're only addressing that part, it's Ray train, Ray data, and not so much, but we're really going to look into it, Ray serve yet. So we're exploring like how, once people have prototyped stuff, if they actually want to do inference, what's that going to look like, and how do we optimize that? Take this?
Oh, yeah. You want to
yeah, I think the question was, we had an existing ML platform, and we have a new one, and I guess the question is about experiment tracking, right? yeah, how do we use SageMaker, things like that. So we had an existing also ML experiment tracking system, and I wish that team was here. They'd probably answer this question a lot better. They're looking into vendor solutions. They're looking into
Weights and bias.
yeah, weights and biases is
ML
one.
flow.
We could ML flow. The tricky part is how do we, if we were to buy something, how do we integrate it with the rest of the Spotify ecosystem? And then if we were to build something, what the cost would be. Again, this kind of build versus buy, trade-offs kind of thing. Not sure if that answers your question though. So it's really context dependent. Yeah, but we did. Cool. We'll be available for questions if people want to come up and chat with us. But thank you for attending our talk.
Thank you very much.